Part 5, Finding Solutions of Polynomial Equations. For the polynomial p of x equals x to the fourth plus 4x cubed minus 2x squared minus 12x plus 9, x equals 1 is a zero of multiplicity 2. Find the rest of the real zeros, their multiplicities, and factor p of x. So we know that we have a 0 at x equals 1, and that one's multiplicity 2. So if I were to factor, I know I'm going to end up with an x minus 1 squared as part of my factored polynomial. So to find the rest of the factors, let's first do synthetic division with 1. So I write my coefficients here and do synthetic division. Bring down the 1. 1 times 1 is 1. Add, we get 5. 1 times 5 is 5. Add, we get 3. 1 times 3 is 3, add we get negative 9, and 1 times negative 9 is negative 9, add we get 0. So I knew I would get 0 as the remainder because I knew x minus 1 was a factor. But x minus 1 is a factor of multiplicity 2. I can now do 1 again, but this time with what I got at the bottom of my synthetic division. Because I know that x minus 1 is a factor 2 times, I can divide twice. Bring down the 1. 1 times 1 is 1. Add, we get 6. 1 times 6 is 6. Add, we get 9. 1 times 9 is 9. Add, we get 0. So I have x minus 1 squared. I knew that part. Now I have an x squared plus 6x plus 9. So I started with x to the fourth. I divided by an x 2 times. So I'm down to x squared. So I have x squared plus 6x plus 9. And then I can factor this the rest of the way. So that is x minus 1 squared times two numbers that multiply together to get 9, add together to get 6 would be 3 and 3. So I have x plus 3 squared. So we have zeros and multiplicities. So 1 is a multiplicity 2, and negative 3 has multiplicity 2. So we factored all the way, we found the zeros, we found their multiplicities. Let's use the graph to solve this equation. We have x cubed minus 11x squared plus 37x minus 35 equals 0. That one does not look easy to factor, but I do know, looking at the graph, that we have an x-intercept at 5. So I'll start with synthetic division using 5. We have 1, negative 11, 37, negative 35. And let's do our synthetic division. We should get a remainder of 0 because 5 is a 0. Looking at the graph, I can't see what the other zeros are exactly. I know the one is somewhere between 1 and 2. The other one is somewhere between 4 and 5. But if I do some synthetic division, maybe I can finish from there, either factor or use the quadratic formula. So I bring down the 1. 5 times 1 is 5. Add, we get negative 6. 5 times negative 6 is negative 30. Add, we get 7. And 5 times 7 is 35. Add, we get 0. So if I were to factor this, I have an x minus 5. And I have an x squared minus 6x plus 7. Now to find the other two zeros, I need to factor or use the quadratic formula with x squared minus 6x plus 7. And that one doesn't factor, so let's use the quadratic formula. So we know x is negative b, so negative negative 6, plus or minus the square root of b squared. So negative 6 squared is 36, minus 4 times a, which is just 1, times c, which is 7, all over 2a, so 2 times 1. And then I'll simplify that. So 6 plus or minus the square root of 36 minus 4 times 7 is 28 over 2, which is 6 plus or minus the square root of 36 minus 28 would be 8 over 2. And I can simplify that a little bit further. I have 6 plus or minus 2 square root of 2 over 2, and dividing everything by 2, I get 3 plus or minus square root of 2. So my solutions to this equation are 5, 3 plus square root of 2, and 3 minus square root of 2. And I knew that by looking at the graph and finding one of my zeros is 5.